Hello learners, this is the unit complex plane again, and in this lesson we are going to learn about the modulus of the complex number. And we mentioned the modulus before, and we studied the modulus but in another name, which was a magnitude of the vector. So in this lesson we are going to identify the modulus in the complex number, whether in the rectangular form or in the polar form. Let's recall the complex number in the polar form or rectangular form first, which is a plus bi, and it's in the polar form a cosine theta plus a sine theta I, where a here is the magnitude or the modulus of the complex number. In rectangular form, the modulus, which is we can call it the absolute value of z, because it's a distance between the origin and the point a plus bi on the complex plane. So the distance between 2 points give us the absolute value of z, or a, which called the magnitude, or the magnitude in the polar form, and it's called the modulus here. So let's recall this triangle here, where z equals a cosine theta plus sine theta I. We have a here is the distance between the origin, which is 0, 0, and this point complex plane, and the distance will be in the form of absolute value. It's always positive wherever it is, because distances are always positive. This is the modulus, or magnitude, or the distance between 2 points. So we can find the modulus in 2 ways. One of them is by x squared plus y squared, or a squared plus b squared, using Pythagoras theorem. The other way, using the conjugate. So z multiplied with the its conjugate, as z equals x plus iy, and its conjugate is x minus iy or yi, it's the same. So the multiplication here is x squared plus y squared. Now, as z multiplied with its conjugate gives us the absolute value of z squared, so we can find only the distance, or the absolute value of z, which equals the square root of x squared plus y squared. So these 2 ways we always find the modulus or magnitude of a point in a complex system or complex plane. Let's see we can refer to it as r, which is the radius. It is the distance between, in polar system, it is the distance between this point P and the 0, origin 0, 0. And this is the radius as well, using Pythagorean theorem. It is the square root of a squared plus b squared, where the opposite is r sine theta and the adjacent is r cosine theta. So r, a, absolute value of z, or r, they are all indicate the same. It is the distance between the origin and a point in complex plane, and it is called modulus. Let's see the properties of the modulus, that we can use the properties sometimes in order to find the modulus. So the modulus of complex number z and z minus are always the same. Why? Wherever the in any quadrant, whether positive or negative quadrant in the complex plane, always z is the same, or a, because it is a distance, and the distance is always absolute value. So absolute value of positive z equals the absolute value of negative z because it is a distance. And the modulus of a complex number can be zero if and only if the complex point is zero. So the modulus is zero only for the point zero on the complex plane, and the modulus of the product of two complex numbers, if we have the complex number z and the complex number w, the modulus of the multiplication of both equals the modulus of, or the product of the modulus of each of them. Now, the same for the quotient of z divided by w equals the modulus of z modulus of w. And the modulus of the conjugate equals the modulus of the complex number. If we have z as a complex number, so the modulus of this complex the same as the modulus of its conjugate, because the difference is in the sign, while in absolute value the sign doesn't matter. It's always positive. And finally, for the nth power of a complex number, any complex number to the power n, the modulus of the complex number will be to the power n as well. Note that the distance between the number represented as a point and the plane, which is AB in the complex plane, and the origin is the modulus of complex, as we know. Just recall this, it is the distance between the origin 0, 0 and the point AB, or the point a cosine theta, a sine theta I, in whatever form it is in the complex plane. So the modulus is only distance, and the distance is always positive. The modulus of complex number a plus bi is the same thing as the magnitude or the length of the vector represented by a, as we call it previously as a magnitude a. So this magnitude a of this vector in polar system, so the modulus is the exact same of value of this vector value. And the modulus of the complex number is the square root of the sum of x squared plus b plus y squared, or a squared plus b squared. These are all just to recall, and let's go find the modulus in a given complex number. This example, determine the modulus of the complex number z equals minus 6 plus 3i. So we have z equals minus 6 plus 3i, where this is y or b and this is x or a, whatever, and the modulus or equals to the square root of x squared plus y squared. It is minus 6 squared plus 3 squared. We have here 36 plus 9, and it is the square root of 45. We can leave it as it is, or just represent it by 45 is 9 multiplied by 5, square root of 9 is 3, it's 3 square root of 5, just for simplification. Let's see another example. Calculate the modulus of the complex number v, which is 1 plus 2i, multiplied with minus 2 plus 3i. It's the product of two complex numbers using the property of modulus of the complex number. And which property will we use here? It's a property that will say the modulus of z w equal multiplied with w equals the modulus of z multiplied with modulus of w. So we have here z and w. They both form V. So in order to find the modulus of V, we need to find each modulus of Z. So the modulus of Z here equals to, we have Z equals to 1 plus 2i and W equals to minus 2 plus 3i. For Z, it's equals to x squared 1 plus 2 squared, so it is the square root of 5, while the modulus of W, the same, the square root of minus 2 plus the square root of 3, while it is 4 plus 9, so the square root of 13. Now, for the modulus of V, which equals to the modulus of W multiplied with the modulus of Z, this one multiplied with this one here, it's give us 5 multiplied with 13. We can find this by 5 multiplied with 13, which equals to square root of 65. So this is the modulus of this complex number that consists of a product of two other complex numbers. That's all for the modulus and complex number, and thanks for watching. See you next lesson.